do, I'm going to continue explain the topics from quiz 10. Okay, so now let's look at this question. Okay, so this question itself, that's really right. So we're looking for the concentration of hydroxide ion. Okay, so then let's write it down. So we're looking for hydroxide ion concentration. Okay, and then the other keyword will be pure water. Pure water. Okay, so as we talk about in the class, if we know it's pure water, this is implied the concentration of hydronium ion will equals to the concentration of hydroxide ion. Okay, and then you go, 30 degrees Celsius. That sounds a little trouble, right? Okay, so because we know that Kw wouldn't equals to 1.00 times 10 to the power negative 14. It will have a different value, okay? And of course, the value is given right over here, okay? But however, we know no matter what, once we say it's pure water, doesn't matter what the temperature, this relationship will be true, right? This hydronium ion concentration will equals to hydroxide ion concentration. This will be true. Also, what else will be true? Kw will equals to hydronium ion concentration multiply hydroxide ion concentration. Okay, so this two will be true. Okay, and now if that's right, that's the situation, then it's not bad, right? We want to know hydroxide and we know the concentration equal to each other, so let's just continue doing this, right? We're swapping this with hydroxide ion, okay, because they're equal to each other. Now we have this, right? So now Kw will just equals to hydroxide ion concentration squared, okay, and then this value we know at 30 degrees Celsius equals to this 1.47 times 10 to the negative 14, okay, and then therefore to solve this hydroxide ion concentration will equals to actually Kw squared, then you put this value inside here, okay, and then you solve for this, and then the answer will be E as electron. Okay, so again for this question is you have to understand pure water have this relationship, and you also need to know this relationship for Kw. Okay, so Kw, this is gonna true, really doesn't matter it's pure water or acidic solution or basic solution. This Kw will always equal to this because for aqueous solution, right, we know that, right, we know if you have water, right, with water. Okay, so that's L, and then that's L. We'll have what? Hydronium and have hydroxide ion. Okay, let me just move it a little. Right, okay, so, and then Kw, remember Kw will just equal to the product over the reactants, but reactants we don't need to worry because they're all just liquid, so it's not going to involve. Okay, so this really comes to this, right? So this is going to be true, doesn't matter it's pure water or acidic solution or basic solution, as long as, right, as aqueous solution will have this relationship. Okay, and then that's for this question. Okay, so then with knowing this, let's keep on going for the next question. Okay, so now this solution itself seems like it's not gonna be neutral solution, right? It doesn't look like it. Okay, it has, we'll see, but it has the concentration of hydroxide ion at is 5.5 times 10 to the negative 5 at 25 degrees Celsius. Once you see the temperature, you go, it is not neutral. Why? Because we know at 25 degrees Celsius, right? If it's neutral, if it's a neutral solution, what's gonna happen? Hydroxide ion concentration equals to hydronium ion concentration, I'm sorry, and then will equals to what? 1.00 times 10 to the power negative 7. Okay, so that has to be a neutral at 25 degrees Celsius. Okay, and apparently it's not. Okay, so then you go, what is it? Let's actually do a calculation because we also need to know what's the concentration of hydronium ion. Okay, as we talked about earlier. Okay, so actually let's borrow this relationship. Okay, so we already know this is what's happening, right? So you have reaction, okay, so have the reaction, and then we know, right, then Kw will equals to hydronium ion concentration times hydroxide ion concentration. In this situation at 25 degrees Celsius, this will equal to 1.00 times 10 to the negative 14. Okay, and then from this question itself, it's given hydroxide ion equals to 5.5 times 10 to the negative 5 molar, okay? And then we can solve for hydronium ion concentration. So this is quite easy, right? So that will be 1.00 times 10 to the negative 14 divided by 5.5 times 10 to the negative 5, okay? We do the calculation, then you get 1.8 times 10 to the negative 10 molar, okay? So then you go, I know how to solve for this, but how do I tell if the solution is acidic, basic, or neutral, okay? So then this goes back to how do you differentiate, right? So we already know if the two concentrations equal to each other, and at 25 degrees Celsius will equals to this value, okay? And then of course the next you can compare, right, the concentration of hydroxide and the concentration of hydronium, which one is bigger. Then just say hydronium. If it's bigger than hydroxide, then that will be acidic. If the other way around, will be basic. Okay, so now the task will be just compare these two values. Okay, one thing you have to recognize that negative 5 is actually bigger than negative 10. The reason for that, negative 10 means you have 10 zeros up front. That's such a small number. Negative 5 means you have 5 zeros up front. Compared to negative 10, that's bigger. Okay, so if we know that, so then that means hydroxide ion concentration is actually bigger than hydronium ion concentration. That means the solution is a basic solution. Okay, so that's why A is going to be our choice for this question. Okay, so again, this question is quite easy, but this easy questions requires you to understand all these concepts. Okay, and then hopefully this is helpful, and thank you for listening.